I have, in the box, we're talking about polynomials in this chapter. A quadratic is just one type of polynomial. The definition of a polynomial, it looks kind of weird, but I want you to get used to seeing things like this. ACT likes to throw things that look really scary on there, and it's really not if you know what you're looking at. So a polynomial function is something that looks like this. Okay, these x's are my variables. The n's represent the powers, and the a's out in front are just our coefficients. So on your little handout, you kind of fill in the blanks. There's a big line, and you need to write what I underlined in blue. So basically, in a polynomial, you're just adding a bunch of powers of x together. You have an x to the fifth, plus a 3x squared, plus a 2x, minus 5, something like that. In these, a few terms that we're going to talk about a lot and are going to be very important when we graph polynomials. The first and foremost is the degree. Our degree is just the highest exponent. The highest power of x we see. It doesn't necessarily have to be the first term. That's usually how it's written, but I could write the terms in any order. We know addition. You can switch orders around. So we have to look at all of them, find the highest power. That's the exponent. And that exponent is our degree. Second thing that we need to look at is the leading coefficient. Again, it doesn't have to be the first thing I see. It's the coefficient. Do you guys all know what a coefficient is? It's the number in front of your x on the term with the highest degree. Okay, so if it's not written where my powers of x are increasing, we just find the highest power of x, and the coefficient of that term is the leading coefficient. What's a constant? A constant is just a term without a variable. So if I have x plus 3, 3 is the constant. So we're going to start just by giving you a few polynomials and seeing if we can pick out these pieces within it. So for each of them, let's give the degree, leading coefficient, and constant. All right, so the first one, the degree, that's my highest power of x. What is the highest power of x? 1. Okay, my leading coefficient. You find the term with the highest power of x. What is the coefficient on that term? The constant, the number by itself. -1. Second one, what's my degree? Leading coefficient. 1. Because you have to take the number in front of that term. Constant. There is none, so we put a 0. All right, last one. What's my degree? 3. The highest power of x is right here. What is the leading coefficient then? And what is the constant? Is that stuff okay? Just kind of getting used to some of the terminology. One thing to note, if your function is just 0, we call that the zero polynomial, and it technically has no degree. Okay, degree is the highest power of x. But if I put 0, isn't that the same as 0x? And that's the same as 0x squared, and 0x cubed, and I can keep going forever. So if it's just equal to 0, we can't have a degree because it could be any x with it. So if it's just 0, there's no degree. Now, if my polynomial is equal to any other number, it does have a degree. If it's just 3, 3 is the same thing as 3 times x to what power? If I put a 1 there, is 3 the same as 3x? What happens if you put a 0 on that exponent? What's x to the 0 power? 1. And is 3 times 1 the same as 3? Yes. So if it's just a constant, whoops, the degree is 0. But if it's equal to 0 itself, we have no degree. All right, today we are mainly focusing, well, not mainly, we're only going to focus on one type of polynomial. We're looking at a quadratic. So what's a quadratic? A parabola. The graph is a parabola. What does the equation have in it? X squared. We've kind of seen that before already. We've seen those x squareds. So it's any function where you could write it ax squared plus bx plus c. All right, we've got some experience with those. We graphed transformations with our parabolas, so we know a little bit about those already. When we have a quadratic, the graph is a parabola. And when we're looking at parabolas, we have two options. They can either open up or open down. Now, whether it opens up or down determines if you have a maximum or a minimum point. So if you have a parabola that opens up, is this point a maximum or a minimum? Minimum. If our graph opens down, then we have a maximum. What's another name for this maximum or minimum point on a parabola? Vertex, yep. That highest or lowest point is your vertex. And remember, when you graph these for Mrs. Keller, you probably had to draw a dashed line going through the middle of your vertex. What was that line called? The axis of symmetry. It's that vertical line that is your line of symmetry. Separates it into two halves. Okay. So when we've graphed these so far, our strategy is to do transformations, right? That's the easiest, most efficient method. We can see a quadratic in two different forms. Standard form is what I had you write down, ax squared plus bx plus c. Vertex form is what we saw in chapter 2 when we did those transformations. F of x equals a times x minus h squared plus k. In this vertex form, you could think of it in the transformations. Your quadratic, when you graph it, it starts at 0, 0. Okay, when you add or subtract something to your x, that moves it left or right. When you put a k on the end, that moves it up or down. So the hk actually gives you the vertex of your parabola. So you could get that from drawing the graph or just by looking at the equation. And then we use our basic transformations to get the graph. So we're going to graph a few. I have 3 of them on here. We're actually going to do A last. Let's do B and C first. Because B and C are set up so we could use transformations to graph those. When I had you do transformations, what did I make you do first? Parent function. So we know a parabola, 0 squared is 0, 1 squared is 1, 2, 4, -2, 4, -1, 1. And I wanted you to always do that dashed. What does the negative do? And what does the 2 do? So we talked about these. Some people could just reason through them. Some of you like to write out the ordered pairs. And we talked about how since this -2 is on the outside, it's really just like multiplying your y times -2. So if I take 0, 0, its y value is 0 times -2 is still 0. Okay, 1, 1. So my y is 1. 1 times -2 is -2. 2, 4. My y value is 4. 4 times -2 is -8. -1, 1. My y is 1 times -2 is -2. Okay, here my y value is 4 times -2 is -8. So we just get a skinny upside down parabola. All right, why don't you guys, oh, actually, I asked a couple other questions on this. I said to give the domain and range, didn't I? What's the domain? -infinity to +infinity, and it will be for every single quadratic. My range, it comes from, yeah, so in interval notation it's coming from -infinity, it stops when we get to 0, so -infinity to 0. Why don't you guys graph the last one with transformations for me? So same parent function. How does this one move?
Right, 3 down there.
Mm-hmm. So you take each of your points right and down. So our vertex ends up at 3, -1. If you think about the formula, sometimes people get really confused on this. The formula is minus h. So the minus, that means my h is just a +3 when I'm looking at my vertex. Then the formula has a plus k, so since it's a -1, it's at -1. So that's where our vertex ends up. What's the domain of this one? -infinity to +infinity. Range? -1 to infinity. Okay, so A is different. Why? It's not in vertex form, so can I use transformations to graph it? No. Okay, so if I just had to go back to the old days of plotting points and making a t-chart, what do you want to plug in? Start with 0. We put in 0, we get -4. If I put in 1, I get 1 plus 4 minus 4, so we get 1. What else? What do we want to put in? We put in a 2. So we get 4 plus 8 minus 4. So we get 8. Do I have a parabola yet out of this? What kind of numbers do I need to pick? Negative. So if I put in -1, then I get 1 minus 4 minus 4, which is -7. Okay, do I have a parabola yet? No, so we have to keep going. -2. So I get 4 minus 8 minus 4, so we get negative 8. And that's still not enough, so we would have to go with negative 3. So then we get 9 minus 12 minus 4, which is negative 7. What happened right there? Yeah, it went back up. If you think about your parabola, it's the same on both sides. You know, if you drew in this line of symmetry, once you find your vertex, then you could think, okay, these points should be mirror images across this line of symmetry. So you could get more points from that. But this way is kind of inefficient because I just had to keep picking points until what happened? Yeah, until I found the vertex and my parabola changed direction. And is there any rule that says the vertex has to be at a nice integer value? No, my vertex could have been at negative 7/8, and it would take me quite a while to find that. So we do not want to have to rely on just plotting points to graph these things. So we would much prefer that they are written in vertex form so we can use transformations. So that's some things that we will do. Talk about how could I write it in vertex form, or is there a way that just by looking at the equation itself, is there a way to find the vertex? Does anybody remember? There was a formula for that. So that would be very useful information, so I'm not just guessing points over and over and over again until I get a parabola out of it. So to find the vertex, we use the formula x equals opposite of b over 2a. I don't know if you guys are interested, but it actually comes from like the quadratic formula. If you take this part of your quadratic formula, that's your vertex, opposite of b over 2a. That gives us the x value. The vertex is an ordered pair, so once I have x, how do I find y? Plug it in. So we use this to get x. There is a formula for y, but I don't think it's necessary to memorize formula when we don't have to. So plug in x to get y. The axis of symmetry is the vertical line going through the vertex. Vertical line is always x equals, so it is also that x equals opposite of b over 2a. Then you've got the vertex, and you have a line that cuts it in half, so we just need another point so we can get the rest of it. An easy one is the y-intercept. Just like with a line, when you want the y-intercept, what did we plug in? A 0 for x. So to find the y-intercept, we let x equal 0. And then we'll be able to get the graph. So I have a few of these on here. We're probably not going to do them all. We'll try a couple, and then we will be ready to stop for the day after we do just a few of these. Okay. So I'm asking you all kinds of questions here. Vertex, axis of symmetry, y-intercept, domain, range, graph it. So we're going to do maybe A and C. Vertex. The vertex is an ordered pair. So we start out with the formula. Opposite of b over 2a. What is my b value? So we have a negative 2 over 2 times, what's a? So negative 2 over 2 is negative 1. Then we need y, so we just plug that in. Bless you. Thank you. So negative 1 squared, 2 times negative 1, minus 5. So 1 minus 2 minus 5 is negative 6. Vertex, for me, you have to write it as an ordered pair. X, y. Negative 1, negative 6. If you have this, you can get your axis of symmetry. It's just x equals what? -1. X equals whatever our x value was. All right, how do we get the y-intercept? Put in a 0 for your x, and we get 0 plus 2 times 0 minus 5, so -5. You can write that as an order pair if you want, but I don't care. I'm not going to require you to. So if I want to graph this, we have -1, -6. The y-intercept is -5. Axis of symmetry is just the vertical line going through that. I require a minimum of 3 points. We have 2. How do I get a third? You can plug in another point. Yeah, you could also just take your y-intercept and reflect it across your axis of symmetry. So it's 1 away from my axis, so if you go 1 the other direction, you would have it. What's the domain? -infinity to positive infinity. What would I write for my range? Bracket -6 to infinity. Is there a way to look at this equation and know if your parabola is going to open up or down? How? If that x squared is positive or negative. So I know this one opens up. We have a minimum value at my vertex. My minimum value is -6. It's the lowest one we hit. Okay, let's do C, and then we're going to stop. Does this one open up or down? Down. So would I have a maximum or a minimum? Maximum. If it opens down, you'd have a high point. Okay, so vertex. We do the opposite of B over 2A. So the opposite of 8 over 2 times -2. So -8 over -4 is +2. Plug that in to get your y. Vertex is the 0.25. So what's the axis of symmetry?
2.
X equals 2. What would the y-intercept be? -3. If you plug in 0 for all of your x's, we just get -3. All right, so if we graph it, put a point at 2, 5, draw the dashed line for the axis of symmetry. With the y-axis at -3. So to get my third point, that's 2 away from my axis, so go 2 the other direction. And then maybe draw a slightly better graph than I did there. I missed my point. What's the domain? Oh, I'm going to keep asking you this question until somebody says negative infinity to positive infinity. What's my range? Negative infinity to 5. We stop at 5 on that one. Okay. We're stopping here today, but we can do some problems. So, page 311, 2, 5 through 8, and 12.